Good afternoon, everyone. Welcome to the week 11th of this tutorial session on the course Principles of Communication System 1. Today we are going to discuss some of the problems based on the week 11th lectures as taught on the NPTEL portal for this course. The questions are basically from the probability, basics of probability. So, coming to the first question, the levels of a four array PAM constellation are S is equal to minus 3 alpha, minus alpha, alpha, and 3 alpha. So the constellation of this PAM signal, I think the battery is discharged, so let it charge for 2 minutes. Then we'll again start this question. So with probabilities, P alpha is equal to twice the probability of constellation minus alpha, and that is the 4 times the constellation of 3 alpha, and after that, that is equal to 8 times the constellation of minus 3 alpha. So So here 4 array PAM is there. So it is given probability of constellation alpha is equal to twice the probability of constellation minus alpha, that is equal to 4 times the probability of 3 alpha plus, sorry, not plus, equal to 8 times the probability of minus 3 alpha. So the constellation is shown like this: alpha, 3 alpha, minus alpha, minus 3 alpha. Okay. So now, so let's suppose probability of constellation minus 3 alpha is equal to x. And we know that total probability should also be equal to 1. So probability of alpha plus probability of minus 3 alpha plus probability of 3 alpha plus probability of minus alpha. So this value should be equal to 1. So now probability of minus 3 alpha is x. So probability of alpha will be 8x, and probability of minus 3 alpha we have already taken as x, and probability of 3 alpha, that is equal to twice of probability of minus 3 alpha, so that will be equal to 2x, and probability of minus alpha is equal to 4x. So 15x is equal to 1. So here the value of x is 1 by 15. So now substitute all the values. So probability of minus 3 alpha is equal to x, so that is equal to 1 by 15. Here also you can write, so probability of alpha is equal to 8 times probability of minus 3 alpha, so 8x, and probability of minus alpha is equal to 4 times, it will be 4x, and probability of 3 alpha is twice, so 2x. So we can write down all the probability. So probability of minus alpha is equal to 4 by 15. Probability of alpha is equal to 8 by 15. And probability of 3 alpha is equal to 1 by, sorry, 2 by 15. Okay. So in this question, it is asking let x1, x2 denote two symbols drawn independently from the constellation. The probability that none of x1, x2 symbols belong to the set minus alpha, comma 3 alpha. So it is asking the probability that none of x1, comma x2 belongs to set minus alpha, comma 3 alpha is. So that is equal to 1 minus probability of minus alpha minus probability of 3 alpha square, because it is drawn twice, like the two symbols has been drawn x1 comma x2. So it will become like it will just become multiplication of 1 minus probability of minus alpha minus probability of 3 alpha. So this is equal to 1 minus probability of minus alpha minus probability of 3 alpha. So this is the square of this. So that is equal to 1 minus probability of minus alpha is 4 by 15. Probability of minus 3 alpha is 1 by 15. So this is equal to 10 by 15. Like when you do the subtraction, after taking LCM 15, we will get 15 minus 4 minus 1 squared. So that is equal to 10 by 15 squared. That is equal to 2 by 3 squared. So it is equal to 4 by 9. Sorry, here it is 2 by 15. Probability of 3 alpha is 2 by 15. So here you write 2 by 15. 15 minus 4 minus 2. So this value is equal to 9. So 9 by 15. So when you divide by 3, you will get 3 by 5. So that is equal to 9 by 25. So the correct answer for this question is option number B, that is 9 by 25. So if you have any doubt, you can ask, and also this video will be uploaded, like recorded and uploaded on YouTube. So the link will be shared in the NPTEL portal. So now we will move on to the next question. So the levels of 4 array PAM constellation are given minus 3 alpha, minus alpha, alpha and 3 alpha. So 2, 4, 4. The values are same, only the last value is 4. So let x1, x2 be two symbols drawn independently from the constellation, the probability that x1 is equal to 3 alpha and x2 is equal to minus alpha. So same, we will solve this question. So there are four constellation of PAM. So in this, again, we will use the probability law that sum of all the probabilities would be equal to 1. So in this question, it is given probability of minus alpha, sorry, probability of alpha is equal to 2 into probability of minus alpha, that is equal to 4 into probability of 3 alpha, that is equal to 4 into probability of minus 3 alpha. So now let probability of alpha is equal to x. Then probability of minus alpha is equal to x by 2. Probability of 3 alpha is equal to x by 4. And probability of minus 3 alpha is equal to also x by 4. So now all the sum, like probability of alpha plus probability of minus alpha plus probability of 3 alpha plus probability of minus 3 alpha. All these sums should be equal to 1. Let me check once the video is recording or not. Yeah, it's recording. So all the sum of all the probabilities would be equal to 1. So now this is equal to x plus x by 2 plus x by 4 plus x by 4 is equal to 1. So this will become 4x plus x, 2x plus x plus x. So x is equal to 1 by 2. So therefore probability of alpha is equal to 1 by 2. Probability of minus alpha is equal to 1 by 4. Probability of minus 3 alpha is equal to 1 by 8. And probability of 3 alpha is equal to 1 by 8. So now in this question it is asking two symbol x1 and x2 are drawn independently from the constellation. The probability that x1 is equal to 3 alpha and x2 is equal to minus alpha. So probability that x1 is equal to 3 alpha and x2 is equal to alpha is probability of 3 alpha into probability of minus alpha. So it is given minus alpha. So here you write minus alpha. So this will become, so probability of 3 alpha is given how much? 1 by 8, and probability of minus alpha is given 1 by 4. So the answer is 1 by 32. So the correct option is option number C, that is 1 by 32. So we'll move on to the next question, that is question number 3. So in a multiple antenna wireless system, the principles that can be exploited to achieve a significant reduction in bit error rate is termed. So this term is diversity. So the principle that can be exploited to achieve a significant reduction in bit error rate is termed as diversity. So option number D is the correct answer for this question. Now moving on to the next question. Given the probability density function fxx of a random variable x, its mean age. So we have already studied in the last tutorial section about mean, variance and all other things. So mean is equal to x of probability density dx, and the value of x will be from minus infinite to infinite. The correct answer is option number B. Now coming to the next question, and after solving this 10 question, today we will solve some gate question also, apart from the lecture series. So consider a binary symmetric channel in that probability of A1 is given as 0.75 and probability of B naught such that A naught has occurred, that is equal to probability of B1 such that A1 has occurred is 0.80. AI and BI denote the events corresponding to transmitted and received symbols. I is 0, 1 at the transmitter and receiver respectively. Then a posteriori probability A1 such that B naught has occurred. In this question, it is asking this. So it is a binary symmetric channel. So let's suppose A naught, A1, B naught, B1. So probability of B naught such that A naught has occurred is 0.80 and probability of B1 such that A1 has occurred is 0.80. So it is asking probability of A1 such that B naught has occurred. Okay. So probability of A1 is given 0.75. So probability of A naught, that is equal to 1 minus probability of A1, that is equal to 0.25. Okay. And probability of B1 such that A1 has occurred, that is equal to 0.8. This implies that probability of B naught such that A1 has occurred, that is equal to 0.2. So this will be 0.2 and this will be also 0.2. Similarly, probability of B1 such that A naught has occurred, that is also equal to 1 minus 0.8, 0.2. Okay. So now we will use Bayes theorem to solve this question. So in this question they have asked probability of A1 such that B naught has occurred. Like B naught has occurred. Now we have to find the transmitted signal was A1. Okay. So probability of A1 such that B naught has occurred, that is equal to probability of B naught such that A1 has occurred into probability of A1 divided by probability of B naught such that A naught has occurred, probability of A1 A naught plus probability of B naught such that A1 has occurred into probability of A1. Okay. So now we have all the values, substitute all the values and get the answer. So probability of B naught such that A1 has occurred is 0.2. Probability of A1 is given in this question 0.75. Probability of B naught such that A naught has occurred is given as 0.8 and probability of A naught is 0.25. Probability of B naught such that A1 has occurred is 0.8. No, sorry, that is 0.2. And probability of A1 is 0.75. So we will get 150 0.15 divided by 0.2 plus 0.15. So that is equal to 0.15 divided by 0.35. So that is equal to 3 by 7. So the correct answer for this question is option number D, that is 3 by 7. Okay. Oh. So we'll move on to the next question. The set of all possible outcomes of a random experiment is termed as sample space. We have already studied sample space is set of all possible outcomes of a random experiment. Okay. So option B is the correct answer for this question. So we'll move on to the next question. And this video is recorded, so it will be uploaded on YouTube, and the link will be provided in the NPTEL portal. So the next question is, the level of 4 array PAM constellations are minus 3 alpha, minus alpha, alpha, and 3 alpha. So here the probability is given as probability of alpha is equal to twice the probability of minus alpha, that is equal to twice the probability of 3 alpha, and 4 times the probability of minus 3 alpha. And the event A is given as 3 alpha comma minus alpha, and the event B is given as minus alpha. So in this question it is asking probability of event B such that A has occurred. So this is just the constellation diagram is like this. This is at alpha, 3 alpha, minus alpha, and minus 3 alpha. So the probability of each constellation is given as probability of alpha is equal to twice the probability of minus alpha. So here we can assume that let the probability of alpha is equal to x. So with that we will get probability of minus alpha is equal to x by 2. Probability of 3 alpha is also equal to x by 2. And probability of minus 3 alpha is equal to x by 4. So we know that sum of all the probability is equal to 1. So probability of alpha plus probability of minus alpha. So this summation is equal to 1. Okay. So here we'll substitute the value x plus x by 2 plus x by 2 plus x by 4. So this value is equal to 1. So value of x is equal to 4 by 9. So now we will write down all the probabilities. So we'll get probability of alpha here as x, so that is equal to 4 by 9. Probability of minus alpha is equal to 4 by 18. So we can write it as 2 by 9. Probability of 3 alpha is also equal to 2 by 9. And probability of minus 3 alpha is equal to 1 by 9, because that is x by 4. So we have got all the probability. Now in this question it is asking probability of event B such that A has occurred. So we know the formula, that is equal to probability of B intersection A divided by probability of event A. So now event A is given as C alpha comma minus alpha. Okay. And event B is given as minus alpha. So what is A intersection B? That is equal to minus alpha. So that is equal to probability of minus alpha divided by, and probability of A. So probability of A is probability of 3 alpha plus probability of minus alpha. So this is equal to probability of minus alpha is 2 by 9 divided by probability of 3 alpha is equal to 2 by 9, and again minus alpha is 2 by 9. So when we do the sum, we will get 2 by 9 divided by 4 by 9. So this is equal to 1 by 2. So from the above options, option C is the correct answer for this question. That is 1 by 2. So now we'll move on to the next question. That is question number 8. So probability density function of a Gaussian random variable of mean mu and variance sigma square is. So we have already studied in the last tutorial session. So the PDF of this function is given as, you can write it as f of x. So this is given as 1 by under root of 2 pi sigma square e to the power of minus x minus mean square divided by 2 into variance. So this is the probability density function of Gaussian random variable. So the correct answer from this question is option number C. So we have also studied this in the week 8, sorry, week 10. So this is the Gaussian density function. So this is the probability density function of the Gaussian random variable. It is given as this formula. Here A is the mean and sigma square is the variance. So you can see this. And also let's suppose a question is given like the probability density function here. So this value is the mean always. This is mu. And this 18 is 2 sigma square. So variance will be sigma square will be 18 by 2. So that is equal to 9. So we have already studied this in the last lecture about Gaussian random variable. So the same question is here. So option number C is the correct answer for this question. So now we'll move on to the next question. Consider the random variable x with probability density function given as beta e to the power of minus beta x for positive value of x. That is x is greater than equal to 0 and less than infinite. And the value of y is equal to under root of x. So the PDF of the random variable y is. So actually this is the question for Like when you find, you will get the relic, like the distribution of the relic channel as taught in the week 11th. Like, so the fy of this formula we have studied divided by dy by dx, and here x is equal to h of y. We'll substitute the value of x is equal to h of y. So y is equal to root x. So x is equal to y square. So we'll substitute that value. So the f of x is given as beta e to the power of minus beta x. Here x is equal to y square divided by dy by dx. So here when you do dy by dx, we'll get x to the power of 1 by 2. So that will become 1 by 2 into x to the power of minus 1 by 2. So 1 by 2 root x. So this dy by dx is 1 by 2 root x, and the value of x is y square. So after substituting this value, so we'll get the density function. Again, I think the pencil got discharged. So we'll wait for a minute. After substituting the value, we will get beta e to the power of minus beta y square divided by 1 by 2, and root x is y. So this will become 2 into beta into y into e to the power of minus beta y square. So now beta is constant. So this is equivalent to the Rayleigh fading channel. Okay. Rayleigh fading channel is used for non-line of sight communication, and Rayleigh fading channel is used for line of sight communication. Now moving on to the 10th question of the today's tutorial session. So the random variable formed by linear combination of Gaussian random variable is Gaussian. So this we have already studied in the lecture. Like if there is a like the summation of like the random variable that is forming by the linear combination of the Gaussian random variable is always a Gaussian. So now we will take some of the questions from the gate, as we have taken in the last lecture also. So in the week 11th, in the week 11th, WSS random process is taught, but the question we will take now, some of the question based on that. First of all, we'll see what is wide sense stationary random process. So, so if a mean and autocorrelation function are independent of time, then the random process is known as wide sense stationary random process. So, we'll write this note point. If mean and autocorrelation function are independent of time, then called as wide sense stationary random process. Okay. So now we'll solve some of the question on this from the previous year GATE questions. So the first is if the mean and autocorrelation are independent of time. So first is mean, let's suppose M1T we denote it as. So that is some constant value, does not depend on time. Second is autocorrelation function, that is E of xt and time shifted version of xt plus tau. This should be the function of tau only. It should be independent of time. Should be function of tau. Okay. So when this is true, then the if these two conditions satisfy, then that function is known as wide sense stationary random process. So now let's take a question. A random process is given by xt is equal to a cos omega naught t plus theta. A and omega naught is constant. Theta is a random variable. That is uniformly distributed in 0 to 2 pi. So find the first part is mean and autocorrelation function. The second part is verify the signal is WSS or not. So first we'll find the mean and autocorrelation function. If that is independent of time, then the signal is WSS. So the first part is mean. So mean is equal to expectation of xt. So this is equal to xt is given as a cos omega naught t plus theta. We'll write a cos omega naught t plus theta. So this will become integration is from 0 to 2 pi as it is given. It is uniformly distributed in 0 to 2 pi. F theta d theta. Now what is F theta? It is given, it is a random, theta is a random variable uniformly distributed in 0 to 2 pi. So if a uniformly distributed it is there, So we know how to plot this curve. So this will vary from 0 to 2 pi, and the amplitude will be 1 by 2 pi minus 0. We have studied in the last lecture. So this is 1 by 2 pi, the amplitude. So S theta is 1 by 2 pi for theta ranging from 0 to 2 pi. So we can write here 0 to 2 pi a cos omega naught p plus theta 1 by 2 pi d theta. So here a by 2 pi is constant, so it will come outside. Now integration of cos omega naught t plus theta will be sin omega naught t plus theta and the value will range from 0 to 2 pi. Here omega naught t is k, constant. So this part will not come, like when you integrate cos theta plus k, like it is independent of time, independent of theta. Let's suppose if you integrate cos theta plus k d theta, you will get sin theta. This k will not affect. So this k is independent of theta. So that's why it will come sin only, and no other constant term from the integration will come. So now substitute the value of theta 2 pi and 0. So we will get a by 2 pi sin omega naught t plus 2 pi minus sin omega naught t. So this omega naught t plus 2 pi, sine is periodic function with the period of 2 pi. So this subtraction will become 0. So the answer is 0. So mean is 0. Now we'll find the second part, that is autocorrelation function. So autocorrelation function is expectation of xt1, xt2. Here t2 is equal to t1 plus tau. Okay. So we can write expectation of a cos omega naught t1 plus theta, a cos omega naught t2 plus theta. So this will become, now this is the formula of cos a into cos b. So that will become a square multiply and divide by 2. So we'll get 2. So 2 cos a cos b it is there. So that will become cos omega naught t1 plus omega naught t2 plus 2 theta plus cos omega naught t2 minus t1. So this will become expectation of a square by 2 cos omega naught t1 plus omega naught t2 plus 2 theta plus expectation of a square by 2 cos omega naught t2 minus t1. Okay. So now we can write this as, so for the first term we will write, so this will become integration of 0 to 2 pi a square by 2 cos omega naught t1 plus omega naught t2 plus 2 theta into s theta d theta. For the second term, we will write integration from 0 to 2 pi a square by 2 cos of omega naught t2 minus t1 f theta d theta. Okay. So from the so now this will become a square by 2. First we'll take the first term. So for first term it will become sine, and this f theta is 1 by 2 pi. So sine omega naught t1 plus omega naught t2 plus 2 theta, and here it is 2 theta, so it will be divided by 2, and value will go from 0 to 2 pi. Now this value will become 0, okay? Plus a square by 2 cos omega naught t2 minus t1. So this integration will become this this term is independent of theta, so this will come out. So cos omega naught t2 minus t1 will come out, and f theta is 1 by 2 pi, and the value will be theta. Theta is from 0 to 2 pi. So this we already see that the first term will become 0, as here we can see like sin omega t plus theta 0 to 2 pi will be 0. So here it is sine function, it will be periodic, so it will become 0. Now for the second term, this will become a square by 2 cos omega naught t2 minus t1 1 by 2 pi into 2 pi. So this will become 1. And also we have assumed that T2 is equal to T1 plus tau. So T2 minus T1 is equal to tau. So we can write as A square by 2 cos omega naught tau. So autocorrelation function is equal to A square by 2 cos of omega naught tau, and mean is equal to 0. So both the mean and autocorrelation functions are independent of time. So here it is a WSS random process. So we can solve one more question. So let's take one more question. The first question we have taken A cos omega naught t plus theta, and it was from like theta is the random variable uniformly distributed in 0 to 2 pi. Same question we will take xt is equal to A cos omega naught t plus theta, and theta is random variable uniformly distributed in 0 to pi. This time we will take 0 to pi and we will see whether it is WSS or not. Verify WSS or not. So first theta will be from 0 to pi. So the amplitude will be 1 by pi. So now we will find the mean. So mean is equal to expectation of xt. So same way we will proceed. So that is equal to integration from 0 to pi A cos omega naught t plus theta f theta d theta. So this integration will become, and f theta is 1 by pi. So a by pi will come outside, and integration of sin, cos omega naught t plus theta is sine omega naught t plus theta. And value of theta is from 0 to pi. So we will keep a by pi sine omega naught t plus pi minus sine of omega naught t. So sine omega naught t plus pi, this will become minus of sine omega naught t. So this will become minus of sine omega naught t. This will again become minus of sine omega naught t. So the mean is equal to minus 2a by pi sine omega naught t. So here you can see mean depends on time t. So for signal to be a WSS, it should be independent of t. So this is not a WSS random process. So again the pencil is discharged. Just wait for a few seconds. So this is not a WSS random process. We will solve the last question for today's lecture. So this time we will take xt as a cos omega naught t plus b sin omega naught t, and omega naught is constant and a and b are independent random variables, each having same zero mean and variance sigma square. So we'll check now. Random process is given by xt is equal to a cos omega naught t plus b sin omega naught t. So this was the previous year GATE question in EC department. Omega naught is constant. A and B are independent random variable, each having same zero mean and variance sigma square. Find mean and autocorrelation function of xt and verify xt is WSS or not. So first we have to find the mean. So in this question it is given A and B are independent random variable, each having zero mean and variance sigma square. So expectation of A is equal to expectation of B, that is given as zero mean, and E of A square is equal to E of B square, that is equal to sigma square, that is given as variance. And as we have studied in the last lecture, We have studied that variance is equal to E of x square, that is mean square value minus mean of square. Okay, this we have studied in the last lecture. Same we will use here. So the MSQ here, like variance is equal to MSQ minus mean square. So mean is 0, so variance is equal to MSQ. And MSQ is expectation of A square is equal to expectation of B square. Now A and B are independent, so expectation of AB is equal to expectation of A into expectation of B. So this value is equal to 0. So now we will find the first part of this question, that is mean. So expectation of xt. So that is equal to expectation of A cos omega naught t plus B sin omega naught t. So this is equal to expectation of A into cos of omega naught t plus expectation of B into sine of omega naught t. So this term is 0. So the mean will be 0 plus 0, that is equal to 0. Now we'll find autocorrelation function. If autocorrelation function is independent of time, then it is a WSS signal. So E of xt1 into x of t2. Here t2 is equal to t1 plus tau. So this is equal to expectation of A cos omega naught t1 plus B sin omega naught t1 multiplied with A cos omega naught t2 plus B sin omega naught t2. So this will become expectation of A square into cos omega naught t1 cos omega naught t2 plus expectation of B square sin omega naught t1 sin omega naught t2. So now E of s is sigma square, and this will become cos of omega naught t2 minus t1. So this will become sigma square cos of omega naught tau. So this is independent of t. So it is a WSS signal. It is a WSS random process. So today we will end up the lecture here only, and this video is recorded and will be uploaded on YouTube. So and link will be also provided. Thank you everyone for attending today's lecture.